Alright, let's talk a little bit about route summarization. It's also known as route aggregation, and it's the process of advertising a contiguous set of addresses as a single address with less specific, shorter subnet mask. That means that you're going to take the IP addresses that are all in a row and put them together and use a shorter subnet mask. SIDR is a form of route summarization, is synonymous with the term super netting. The SIDR ignores the limitations of classful boundaries and allows summarization with masks that are smaller than that of the default classful mask. And this type of summarization helps reduce the number of entries in your routing updates and lowers the number of entries in your local routing table. Keep in mind the lower number and the larger area that it covers, the faster your routing and your netting is going to be. Here you can see how you can calculate the summary routes. Here in this particular one, you're going to list your networks in binary format. You'll count the number of far left matching bits to determine the mask. So here we have 14 bits that match, so it is a 14-bit subnet. So then you would copy the matching bits and add 0 bits to determine the network addresses. So here we have 172.20, and then the rest are zeros. Here is an example of the static routing example. Okay, we've gone from 172.16.10, 172.16.20, 172.16.30. It's summarized into 172.16.00 because the first 22 bits were alike, so that made up our network there when we summarize that static route. Aside from the fact that IPv6 addresses are 128 bits long and written in hex, summarizing IPv6 addresses is actually similar to the summarization of IPv4. It just requires a few extra steps because the abbreviated IPv6 addresses and hex conversion. You can have multiple static IPv6 routes that can be summarized into a single static IPv6 route if you have to make these requirements. If the destination networks are contiguous and can be summarized into a single network address, the multiple static routes all use the same exit interface or next hop IPv6 address. So in order to calculate this IPv6 network address, if we're going to summarize it, you list the network addresses, the prefixes, and identify the part where the addresses differ. Then expand the IPv6 if it's abbreviated, convert the differing section from hex to binary, count the number of far left matching bits to determine the prefix length for the summary route. That's the part that's very similar to your IPv4. Copy the matching bits, then add 0 bits to determine the summarized network address or the prefix. Convert the binary section back to hex, and then append the prefix to the summary route. And that's what we came up with in step 4. Here you'll see where we've removed the static routes and we configure the summary IPv6 routes. I don't expect you to do this in your head. You'll definitely need a good calculator that goes from hex to binary and binary to hex to help you figure this one out. We can have floating static routes, and there's static routes that have an administrative distance greater than the administrative distance of another static route or dynamic route. Remember that from our previous conversation. The administrative distance has to be greater. The administrative distance of a static route can be increased to make the route less desirable than that of another static route or a route learned through a dynamic routing protocol. And this way the static route kind of floats, and it's not used when the route with the better administrative distance is active. It's there, but if there's something with a better administrative distance, It uses the best administrative distance for that active route. However, if the preferred route is lost, and remember it can be lost because a line's down, equipment's down, the floating static route can take over and traffic can be sent through this alternate route. So here you see we have our different IP routes. You have a quad 0 that's wanting to leave out of the 172.16.22, and then we have another one, or our floating route, that lets you go out of IP route quad 0 from 10.10.10.2. You use the show IP route command to verify that the routing table is using the default static route. You can use trace route command to follow the traffic flow out the primary route. Disconnect the primary link or shut the primary exit interface down to see that the floating interface is going to work. Use show IP route command to verify that the routing table is using that floating static route. And then you can use trace route command to follow the traffic flow out the backup route. That's the way you can make sure that both your standard static route is working and your floating is working.